Good morning. So in this particular video, we're going to discuss the distillation, single stage distillation module, part 1. Okay, single stage distillation module, part 1. Ang application ng distillation ay sa production of gasoline, diesel, and other petroleum products. And then locally, we use this to produce liquors, no, like lambanog, gin, to name a few products. So we're going to discuss the 5 types of distillation. Differential distillation, plus distillation, simple continuous, stream distillation, and then the multi-stage fractional distillation. So distillation is introduced in organic chemistry laboratory, wherein you perform a laboratory scale distillation process. So generally, meron kayong sample or raw material, and then part of that sample or raw material is evaporated using heat, and then the portion that is evaporated is converted to liquid, no, using a condenser. Generally, the liquefied vapor is the product of distillation, known as distillate. And then in alcohol or in alcohol distillation, what remains in the original container is most of it is water, no? That's why in textbook we call that as waste or W. So in batch distillation or differential distillation, we generally use an equation. This is known as the Rayleigh equation. So if you still remember your chemical engineering calculation, in distillation you have six variables: dxd or fxf, that is your feed, the concentration of the feed; dxd, distillate, the concentration of the distillate xd; and then waste w, and xw, the concentration of your waste. So all in all, you have 6 variables. So in chemical engineering calculation, generally 4 variables are given, and you can set up 2 equations to solve the other 2 variables. So in unit operation, we have another equation, the Rayleigh equation, which will give us 3 equations. So because of this equation, you will only need 3 unknowns in order to solve the other variables. Okay, so for example, you know the amount of feed. Halimbawa, you have one gallon of tuba, no? That's fermented coconut sap. And then approximately the concentration of alcohol in the tuba is 5%. So that's another known variable, X sub F, And then the concentration of, halimbawa, you need to, you know that the concentration of lambanog is 30% alcohol. So that would be XD. So all in all, you have three known variables. Unfortunately, if you're going to use the 2 equations, the overall mass balance and the alcohol balance, you will only have 2 equations. So you cannot solve the other variables. For example, you can find how much alcohol how much lambanog are you going to produce before you stop the distillation? No? You won't be able to calculate D. Pero with Rayleigh equation, you will have three equations and you can solve D, or the amount of alcohol, or the amount of lambanog that you're going to produce before you stop the distillation. Okay, so that's the practical application of the Rayleigh equation. So let's take a look at the Rayleigh equation. So the first variable here is F. No, the first variable is F. This one. The first variable is F. So F is the amount of feed. This could be in mole per hour, or in moles, or in kilogram, or in pounds. So that would be F. This is the amount of the raw material. Ano? Tapos, next is X sub F. X sub F is the concentration of the more volatile component in the feed. So, in the case of water and ethanol, that would be ethanol. Ano? This is the concentration, either mole fraction or mass fraction of ethanol in the feed. Then next is W. So W is the residue or the waste. That's why it's W. So this is either the kilogram or the pounds of W, or the pound mole or kilogram mole of the liquid that remains in the original container. That would be your W. And then XW. XW is the concentration of, is still the more volatile component in the waste or the residue. Okay. So we're going to illustrate this. If this is your distillation system, and then this is the feed, this would be X sub F. And then what will remain in the container would be the waste. And that would be, the concentration of the waste would be XW. And then generally the product is D. And then the concentration of D is expressed as dXD. So as you can see, we have 6 variables. These are the 6 variables of distillation. Ano? In Chicalc, generally four variables are given so that you can solve the 2 other variables. No? Pero in unit operation, generally only 3 variables can be given. And then using the Rayleigh equation, you can solve the other 3. Because right now, we will have 3 equations. Okay? And then the last variable is alpha AB. So alpha AB is the relative volatility. This is the relative volatility of A with respect to B. So basically, this is a ratio of volatility of A with B. Volatility of B. So what is volatility? Volatility is measured as this directly proportional to the vapor pressure. No, it's directly proportional to the vapor pressure of the substance. Pero just like other concept, to make this independent of concentration, we generally divide this by the concentration. So in the case of volatility, we divide this with the mole fraction of A, or X sub A. So this is how we define volatility. Vapor pressure or partial pressure of a substance in a solution divided by the mole fraction. So let's try to derive the Rayleigh equation. So in the derivation, we will be able to review some of the concepts in physical chemistry, and we're also going to derive some intermediate equations that are generally used for solving distillation problem. So let's start with alpha AB. Let's start with alpha AB. So this is defined as relative volatility or B sub A over B sub B. And then I've told you that B sub A is defined as P sub A over X sub A. And also B sub B is also equal to P sub B over X sub B. Then you substitute both of this equation to the first equation, to the alpha AB equation. So you're going to get alpha AB is equals to P sub A over X sub A divided by P sub B over X sub B. And then we assume that the system follows the ideal gas law. So when we assume ideal gas, if you still remember, we can say that the mole fraction of A in the vapor, no, is equal to P sub A divided by the total pressure of the system. Why is this so? Because if you're going to substitute, kasi di ba the original definition of Y sub A is number of moles of A divided by total number of moles. Tapos if you're going to use the ideal gas equation, but the ideal gas equation is PV is equals to nRT. So N sub A is PB, or that's P sub A, B divided by R divided by T. And then NT is P total B over RT. So all the other variables will cancel out. Of course, gas R is gas constant that will cancel out. They are on the same container, so the temperature are the same, no, and they occupy the same volume. So in an ideal gas system, no, P sub A divided by P sub T is equals to mole fraction of A or Y sub A. Y sub A is the mole fraction of A. Yan na. This is mole fraction of A in the vapor or in the gas. Okay. So we substitute this equation. We're going to, as you can see, P sub A from this equation, P sub A is PT times Y sub A. So if we're going to substitute this equation to the original equation, you're going to get PT Y sub A X sub A divided by X sub A PT times Y sub B divided by X sub B. This is supposed to be X sub B. Okay, and then PT will cancel out. And what we have here is the classic distillation equation of alpha AB is equals to Y sub A over X sub A divided by Y sub B over X sub B. Hindi ko lang talaga alam kung ano yung tawag dito sa equation na to. Pero this is frequently used in several distillation problems. In fact, pag merong given na distillation problem tapos parang wala kayong idea kung paano siya isosolve, we usually resort to this equation. Ano? Another thing, yung Y sub A over X sub A, kung natatandaan nyo sa PChem, this is defined as the equilibrium ratio. So, yung equilibrium ratio K of a particular substance is available sa handbook. Ano? So, basically, alpha AB, if we're going to use the handbook to find alpha AB, is basically equal to K sub A, the equilibrium ratio, divided by K sub B. Yun yung ano na. So, Basically, what we're doing here, what we're trying to accomplish is to derive the Rayleigh equation. Pero yun nga, in the process, we have also derived this equation, which is, as you can see, I will demonstrate that we're going to use this in the distillation problem. Okay, so let's proceed. So we start with this equation. Alpha AB is equals to y sub A over x sub A, and then y sub B over x sub B. Okay. So y sub A, let's consider this system. Halimbawa, originally you have A moles of A and B moles of B, no? In a still. This is a distillation equipment. Tapos you apply some heat. You apply some heat to the system. So what will happen is a small portion of this will evaporate. So a very small amount of A will evaporate, and also a very small amount of B will also evaporate. No? So this results in a lesser amount of A in the still. This is your waste, A minus D sub A, and B minus D sub B. So basically, this is your distillate, and then this is your waste. Okay. So what I'm going to do is, I'm going to rewrite, or I'm going to define y sub A from this system. So y sub A, as you can see, is equal to D sub A divided by D sub A plus D sub B. And then y sub B would be equal to D sub B plus divided by D sub A plus D sub B. Okay. What about x sub A? X sub A would be equal to A minus dA divided by A minus dA plus B minus dB. I hope you can see the reason why y sub A is D sub A over D sub A plus D sub B. No? Because as you can see, D sub A, this is the number of moles of A. And then in order to find out the mole fraction of A, you simply divide the number of moles of A with the total number of moles. Ganun lang naman yan. Ganun din sa x sub A. So sa x sub B, you will have B minus D sub B divided by A minus dA plus B minus D sub B. Okay, and then we substitute it right here. So D sub A, y sub A is dA over D sub A plus D sub B divided by XA, this one, A minus D sub A divided by A minus D sub A plus B minus D sub B. Tapos, YB is DB over D sub A plus D sub B. Tapos ito na, XB. XB is B minus D sub B divided by A minus dA plus B minus dB. So as you can see, we can cancel some terms, similar terms. Like for example, this one is similar to this one, so we can cancel that out. Tapos this term dA plus dB is also similar to this one, so we can cancel that out. Tapos D sub A is very much less than A, so we can also cancel that out. D sub B is very less than B. So what remains after cancellation is alpha AB is equals to D sub A over A divided by D sub B over B. Okay? So, ano lang yun. Ano? Let's remember, we're trying to derive the Rayleigh equation. Ano? So with this, alpha AB is equals to D sub B over B, D sub A over A. Let's consider again our system. Ano? We will start with A and B. This is the original A. So actually what we're going to do is we're going to integrate this, no, from B1 to B2. So ano ba yung B1? B1 is the original amount of A. Tapos B2 is the amount of number of moles of B in the waste. Tapos we also integrate this. This is A1. This is A2. Okay, A1 is the original amount of A in the sample or in the raw material. Then A2 is the amount of A in the waste. So parang this is A1, this is B1, and then when a portion of this evaporate, so you will have parang DA at saka DB, merong walang DA at saka DB, differential amount of A and B. So what will remain is actually A2 at saka B2. Ganun yung ating sistema. No? Okay? So nag-apply tayo dito ng heat para merong mag-evaporate and then you have A1, B1, A2. Okay? So pag in-integrate nyo to, pag in-integrate nyo itong equation na to, you will have alpha AB would be equal to ln, no? B2 over B1, tapos ln A2 over A1. Tama? Okay. So what we're going to do is we're going to express, for example, B1 in terms of F and W, in terms of XF, in terms of XW. So, i-compare natin tong system na to sa distillation system. So, if you have a distillation system, may pumapasok tayong F, feed, tapos ang concentration niya XF. Okay? May lumalabas na W, ang concentration ng W, XW. Tapos may lumalabas na D, ang concentration ng D, XD. How do you express, for example, A1? How do you express A1? So remember, A1 is the original number of moles of A in the sample. So A1 would be equal to F XF. And then B1 will be equal to, remember, XF is the concentration in terms of the more volatile component. No? So B1 is the less volatile component. So B1 is, kung binary lang, dalawa lang yung component, that would be F times 1 minus XF. Okay? So what about A2? A2 is the number of moles of A in the waste. So dito, meron tayong W. So it would be W times XW. Eh, what about B2? So B2 would be W times, dalawa lang ang component natin, 1 minus XW. Okay? So when you substitute all these variables, no, all these equations into what we have derived so far, you will have the Rayleigh equation. Alpha AB and then ln. B2 is W1 minus XW. And then B1 is F1 minus XF. And then ln. A2 is WXW. And then A1 is FXF. Okay? So if you're going to multiply both sides by -1, yung F1 minus XF pupunta sa taas, yung FXF pupunta rin sa taas. Ano? So you will have the Rayleigh equation. So this is the Rayleigh equation. Okay. So we're going to use the Rayleigh equation to solve a problem. So a solution containing 30% by weight toluene and 65% by weight benzene is subjected to a simple batch distillation at atmospheric pressure. So for this purpose, assume relative volatility is equal to 3. So the first thing that we need to determine is what would be X sub F. Which of the two is the more volatile component? Kasi X sub F is always expressed in terms of the less, with the more volatile component, with the more volatile component. So the samples are benzene and toluene. Okay. So benzene has a lower molar mass compared to toluene. So benzene is the more volatile component. So XF would be equal to 0.65. If the distillation is discontinued when the weight of the distillates amounts to 45% of the charge, you need to calculate the amount of benzene in the distillate as percent benzene in the charge. So as you can see, the direct variable that we can use for distillation is only XF, which is 0.65. And no other direct variable is given. You know? So in these cases, when you have less number of variables that is given, but you have other data like 45% of the charge become distillate. In this particular type of problem, you need to use a basis. No? So, halimbawa, use 100 kilogram as your basis, 100 kilogram of feed as your basis. So automatically, you will have 45 kilogram of distillate. So, yung XF na 0.65, tapos yung 100 kilogram na feed, tapos yung 45 kilogram na distillate, you have three known variables. So just perform the overall mass balance, no? Just perform the overall mass balance, and then just perform the overall mass balance, and then the benzene balance, and then the Rayleigh equation. And then basically you can solve all the other variables. Ano? You have three equations. And then you're being asked to calculate the amount of benzene in the distillate as percent benzene in the jar. So basically that would be dxd divided by fxf times 100%. So you need to find d and xd. So that's how simple this problem would be. Ano? Okay, so first let's try to draw the system. So we're going to use 100 kilogram as our basis. So this enter our steel. Tapos ang concentration niya ay 0.65. Tapos this would be, we don't know the amount of waste and the concentration of waste. Pero it's given in the problem that if you have 100 kilogram of feed, you should be producing 45 kilogram of distillate. As you can see, hindi rin natin alam yung concentration ng distillate. Okay? So we're going to solve this problem first by performing an overall mass balance. So sa distillation, generally, the overall mass balance is F is equals to D plus W. So F is 100 kilogram. And then D is 45 kilogram. And then W. W is equals to 55 kilogram. Okay? And then we're going to perform a benzene balance. Let's perform a benzene balance. So basically, this is FXF is equals to DXD plus WXW. And then you just substitute the values of each variable. So for F, we have 100, XF is 0.65, and then D is 45, XD is unknown, W is, nasolve natin kanina, it's 55, and then XW. So next, let's set up the Rayleigh equation. As you can see, with the benzene balance equation, you cannot solve XD and XW. You know, you have two unknowns. So the only way to solve this problem is to set up the Rayleigh equation. So Rayleigh equation is alpha AB F 1 minus XF W 1 minus XW, and then FXF divided by, we forget the ln, ln, FXF divided by WXW. Okay, so just substitute. Alpha AB is 3, as given in the problem. Tapos times ln of F, F is 100. Tapos 1 minus 0.65. Tapos W, W is 55. 1 minus XW. XW is unknown. And then F is 100. Except again is 0.65. So W is 55. Tapos 1 minus XW is also unknown. Okay? So using your calculator, try to solve XW. Hey, I forgot to place an ln right here. There should be an ln right. Probably it would be faster for your calculator to solve this when you put an estimate. So as you can see, since your feed is 0.65, probably the concentration of your waste is less than 0.65. So say for example, you place 0.1 as an estimate of the solution. So shift solve point 1. Para mas mabilis. So I'm getting 0.5169 for XW. So with 0.5169, all you need to do is substitute this value right here. And then try to solve, try to solve XD. So XD would be I'm getting 0.8132. XD is 0.8132. And then to calculate the percentage of benzene in the distillate, that's basically DXD divided by FXF, times 100%. So using your calculator to find that value, D is 100 times XD, 0.8132, all over FXF. F is 100, sorry. D is just 45, Tapos, 100 times 0.65. Okay, so times 100%. So I have 56.26. So that's the answer, 56.26. Letter D. So basically, it's just a matter of solving the unknown using 3 equations. Okay, so let's try to solve another one. Okay, so this one, you have a mixture containing 0.65 mole fraction of A and 0.35 mole fraction of B. This is subjected to a simple batch distillation until the instantaneous composition of the vapor leaving becomes 0.55 mole fraction of A. So medyo advanced, medyo iba yung problem na to, compared sa mga basic distillation problem, batch distillation problem. This one involves an instantaneous composition of the vapor. Basically, ang complication nitong problem na to, yung given na instantaneous concentration ng vapor, hindi yun equal sa XD. No, hindi siya equal sa XD. So, you really have to use the alpha AB equation na y sub A over XA, y sub B over XB. Para ma-solve niyo yung para ma-solve yung XW. Yun yung gagamitin dito. Pero once you got XW, and then you got X sub F, and then just use a basis, so 1 kilogram or 100 kilogram of feed, you will have three known variables. Relative volatility is given as 2.5. Basically, you are just asked to estimate the average composition of the total distillate collected. Basically, you're asked to solve for XT. A is more volatile than B. So basically, ganun lang yun. You just need to use alpha AB is equals to y sub A over X sub A divided by y sub A over X sub B. Y sub B over X sub B to find XW. yung kailangan nyo lang intindihin sa problem na to is the fact na yung XD, kailangan nyo lang ma-realize sa problem na to, ano? Is the fact na yung instantaneous distillate concentration, we can call it XDI, the instantaneous distillate concentration, is actually not equal dun sa actual XD. Hindi sila equal, no? Hindi sila equal. Why is this so? Kasi imagine this system, ano, meron kayong feed, yung feed nyo nandito sa loob ng steel, tapos initially ang concentration niya XF, ano? Tapos you heat it, no? So what happens is, at the start of the operation, most of those that evaporate are the less volatile component. Pero as you go along, no, yung nag-evaporate na contains much of the less volatile component. No, nag-iiba yung ano, yung concentration nung vapor. No? And then basically you have a condenser, right here. You have a condenser right here. Tapos you're going to produce the distillate, and then you collect the distillate in a container. So as you can see, the concentration of the distillate is the average of the XDI, and definitely it's not equal to XDI. That is one thing that you need to realize. That's why we need to resort to equation alpha AV y sub A over x sub A is equals to y sub B over x sub B. Yung equation na yon, yung alpha AV is equals to y sub A over x sub A divided by y sub B over x sub B. Ano to? Instantaneous to. No? Palagi itong instantaneous. Ngayon, yung x sub A at saka x sub B, equal yan sa XW. Yung x sub A, equal yan sa XW. Ito namang XB, equal siya sa 1 minus XW. Bakit? Kasi, as you can see, ito, siya yung liquid dito, yung waste, palagi siya yung in-equilibrium dun sa vapor. So, kung ano yung XWI, yun din yung XW. That's the thing you need to realize. So, Y sub A would be the given. Yun yung given na instantaneous, that would be 0.55, no? That would be 0.55. Tapos itong sa baba is 1 minus 0.55. So, since alpha AB is equals to 2.5, diba? 2.5 tapos 0.55 is 2.5. You can actually at this point solve for XW or XB. So XW is 0.3284. No, XW is 0.3284. Yun. So, let's go back to the problem. So with this, halimbawa, we're going to use, ang basis natin is F is equals to 100. Palaging ganun, basta Kasi mole to, no? So 100 kilogram mole. Palaging ganun, basta kulang yung kulang yung given, magbe-basis kayo para dumami, para madagdagan siya ng isa. So 100 kilogram mole yung F, and then XF is 0.65, and then we have just solved that XW is equal to 0.3284. Okay, so tatlo na yan sila. So what we're going to do is we're going to perform an overall mass balance. Ganun pa rin, yung tatlo pa rin. Overall mass balance, A balance, tapos Rayleigh, until we'll be able to solve XD. No? Probably let's clear this out. Okay, so gandaan natin yung drawing yung natin. Ang ating steel. Ang ating diagram. So, ang basis natin is F is equals to 100 mole or kilogram mole para sa mga yan. And then XF is 0.65. XW is 0.3284. Yes. Tapos, hindi natin alam ang W. Yung D at saka XD. XD yung pinapahanap. Hindi rin natin alam. So, the equations, first, let's start with overall mass balance. So, it would be F is equals to D plus W. So, F is 100. Okay, D is unknown, W is unknown. Tapos, let's perform an A balance. So, A balance is 100 times 0.65 dxd plus W 0.3284. So, we can solve these two equations kasi tatlo yung unknowns. So, we need to use Rayleigh. So, Rayleigh, alpha AB, ln, F, 1 minus XF, tapos W, 1 minus XW, tapos ln, F, XF, plus W, XW. So alpha AB is 2.5 ln, F is 100, 1 minus 0.65. Tapos sa baba, unknown, and what we're going to do is W, tapos minus WXW. We can substitute 100 minus D sa W. So from the overall mass balance, we can get that W is equals to 100 minus D. Ganun lang. So that would be W. 100 minus D. Tapos negative WXW naman, how do we find that? Ito yun, Ito naman yun. So, 100 times 0.65. So, negative 100 times 0.65. Ito yun. From this equation. Tapos, minus dxd. Paano ba yung mas shorter? Ang mas shorter pala is na lang. Kasi alam natin yung XW eh. Ang shorter pala ay ayan. Ang shorter pala ay minus W x W. Basically, it's ano na lang. Kasi we have the XW value eh. So W na lang yung unknown dito. Sorry. So since W is W na lang yung unknown natin. Ano? So W tapos 1 minus 0.3284. Tapos LN, dali lang pala. 100 tapos 0.65. Again, W and then 0.3284. And then just try to solve W. Pag na-solve na yung W, you can solve D from the first equation. Tapos substitute do sa A balance equation, you'll find XD. Ano, XD lang naman yung hinahanap. So let's try to solve W using our calculator. Maybe 2.5 times ln 100 times 1 minus 0.65. Tapos alpha x times 1 minus 0.3284. Don't forget the ln. Ano ba? May ln ba ako sa una? So, yan, probably diretso na lang, zip solve lang. May syntax error ako. Sandali lang. Kulang ng parenthesis. Okay. So you'll be able to solve for W. You're supposed to get 21.41. Yeah, it's supposed to be 21.41. You should be supposed to get 21.41. Whether mole or kilogram mole, ano? So with this, you just try to solve D from the first equation. So 100 minus 21.41 D is 78.59. Tapos substitute this to equation right here. This one is 21.41. This one is 78.59. So you'll be able to get XD. XD yung hinahanap. We're supposed to get 0.74. Ano? So that would be letter B. And then, so you need to solve the three problems. I'm going to post this PowerPoint, and then you need to solve the 3 batch distillation problem. No? This one, you need to solve this one, and then you need to scan and attach your solution, the blackboard. Also this one, and finally this one. Okay, tatlong problems. Distillation exercise 1, distillation exercise 2, and distillation exercise 3. So that would be it for differential distillation. Bye-bye until the next video. Okay, guys. You can ask questions sa discussion. Tsaka pag may problema, magmi-meet na daw tayo eh, parang 30 minutes each week. So schedule ko na lang kung kailan. Kasi Friday ngayon, probably next week, no? I-announce ko na lang next week. In the meantime, please try to solve the 3 problems. Kung kaya nyo namang i-solve as soon as possible. Pero syempre walang deadline, ano? Ilalagay ko na lang dun sa last day nung SEM yung you can still submit. You can still submit until the last day of the term. Okay. See you sa next video natin.